Let's solve another problem involving mechanical energy, but this time using potential energy. So here is the problem that we are given. An automobile weighing 2,500 pounds force increases its gravitational potential energy by 2.25 times 10 to the fourth BTUs. It does this when going from an elevation of 5,183 feet in Denver to the highest elevation on Trail Ridge Road in the Rocky Mountains. What is the elevation at the high point of the road in feet? Well, let's see how we're going to solve this. We'll start with the given data. We know that the weight of the car is 2,500 pounds force, that the change in potential energy in climbing the road was 2.25 times 10 to the fourth BTUs. And we know the initial elevation is 5,183 feet. We also know that we can write the potential energy change as mg times z2 minus z1, where z2 is the final elevation, and that is the unknown that we're looking for. And z1 was given as the elevation in Denver where the car started. So we can rearrange this equation and we get z2 minus z1 is delta PE, the change in potential energy, over m times g. But the weight of the car is mg, and we already have the weight of the car. So we don't need the mass and we don't need the acceleration of gravity. We already have the weight. So substituting, we get z2 minus z1 is the change in potential energy divided by the weight of the car, or the final elevation is equal to the original elevation plus the change in potential energy divided by the weight of the car. Okay, inserting values, we get z2 is equal to z1, that being 5,183 feet, plus the change in potential energy, which was given as 2.25 times 10 to the fourth BTUs, divided by the weight of the car, which is 2,500 pounds force. And now we need a conversion. We need to convert BTUs into foot-pounds force. And there are 778.2 foot-pounds force in a BTU. These units will cancel, leaving us with nothing but feet. So Z2, which is the elevation of Trail Ridge Road in the Rocky Mountains, the destination of this car, it is 12,187 feet.